5-2b.
So it's just out. Like you drove down from AP to here.
Increasing and decreasing functions. Now, of course, you can go to your calculator and graph these and see where they are increasing and decreasing. But we're not going to do it that way because that's boring. Yeah, we're going to use calculus to figure out where our graphs are increasing and decreasing. It is. All right, so here we go.
Haven't you learned yet that nobody cares?
Hey, remember what you said that about last week?
Ew, what is that?
We want Derek. Hey, remember when you were making me feel bad about the last week when they got.
All right, shh. Here we go. Now, take a look at this graph that I drew. Shh, guys. Shush. All right. So this graph right here is just a polynomial, regular graph. And we're going to talk about where this graph is increasing, where it's decreasing, and where it's 0. Now, you know where this graph is 0, right? It's 0 at the maximum and at the minimum, and you know how to find that. That is to take the derivative and set it equal to 0. Okay, those are our extreme values. You also might need to check endpoints too, and where f prime of x is undefined. But right now, we're just looking at a parabola. So f prime of x will never be undefined. It's just going to be f prime of x is 0. So if you take a look at this and you think about what the derivative is. Remember, the derivative is the slope of the tangent at any point, right? We forget that. We just take derivatives and we don't remember what they are. So for example, if I were to take this point right here and I look at the tangent line, is that a positive or a negative slope? Positive. Going up positive, right? If I go over here in this area and I take the tangent line, that would be going like this. That would be a negative slope, okay? So this graph is going to be increasing whenever my derivative is what? Positive. Exactly. So when f prime of x is greater than 0, my graph is increasing. Okay, in the middle here, this middle section, we are going decreasing. Okay, decreasing is when your y values are getting lower as you go along the x-axis from left to right. And so that would be when f prime of x is less than 0. My function is decreasing. So instead of being able to graph it and tell me, oh, this graph is increasing from negative infinity to -1, and then it also increases from whatever that x value is to here, okay, that's increasing again, that's when the derivative is greater than 0. So we're going to test the derivative instead of look at the graph of it. So here we go. Are you ready? Let's do it. Number 1. Let's take a graph. What did I say? Something bad?
When it's undefined, what does that mean?
Oh, when the derivative is undefined, that might be a corner or a cusp or a discontinuity of some sort. Yeah, so this graph, like if you had an upside down absolute value graph, it's increasing here, decreasing there. This right here is an important point. It's where the graph's undefined, and it splits it into increasing and decreasing on either side.
Wait, is that a maximum or not?
That would be, yeah.
Oh, okay.
It'd be an absolute max, too, if this was the graph of a regular absolute value, upside down. All right, so let's look at the behavior of this graph right here. F of x equals, I think this is one of the ones that was on your, on your quiz. F of x equals x cubed minus 12x. And so what we're going to do for this is we are going to analyze the behavior of this graph. That's what they call it sometimes. Analyze the behavior. I don't really like that because it's not very specific. I would rather say to you, ask you questions like this. A, find any max and mins. And B, find out where the graph is increasing or decreasing. Okay? Instead of analyze the behavior. All right, so here we go. Your first step to figuring out these two answers for A and B is you're going to take the derivative. Okay, there are no endpoints, so don't worry about that. And we're going to take the derivative of our function, which you all can do. So you take the derivative and you get 3x squared minus 12. Okay? Set this equal to 0 and solve. So add 12. Divide by 3. So x equals plus or minus 2. Now, what I like to do is I like to set up I don't know if it's a chart, I guess, but this is kind of what I like to do, or more like a number line. Chart kind of gets kind of big. So let's go ahead and put negative 2 here and positive 2 here, okay? And at these points, our derivative is 0. All right, so f prime of x is 0 here, and it's 0 here. And what we're going to do is we're going to test the derivative in these intervals. I want to test this interval, I'm going to test this interval, and I'm going to test this interval in the derivative. Okay? So here's what you get to do. You get to pick any point you want to. Any point from negative infinity to negative 2. What point would you like to choose? What x value?
-3.
Me too. Negative 3. So I'm going to test f prime of negative 3. Not f of negative 3, but f prime of negative 3. I'm deciding whether the derivative is positive or negative here. Okay? So I plug negative 3 into the derivative. We don't care what the answer is. We care what the sign of the answer is. Okay? So what would the sign be here? 3 times negative 3 squared minus 12. That's going to give you a positive right there. Okay? All right, let's go ahead and test the derivative on the inside. What would you like to choose here?
2 over 2.
No, I would like to choose 0
Okay.
or 1. 1 would work fine.
4, 7.
So add 2 over 2. All right, f prime of 0 will give us 3 times 0 squared minus 12, which gives us 0 minus 12 is negative. Okay? All right, and then we will test over here. I would probably pick 3, not 2 pi. And I would get 3 times 3 squared minus 12, and that's going to give me a positive answer. Now, polynomials are pretty boring for the most part. No? I mean, I love them, don't get me wrong, but they kind of act the same way. It's like positive, positive, you know. All right, so then we can say from our little chart right here, this is positive, so this is increasing. So our graph is increasing from negative infinity until negative 2. Now, I think your book might put a bracket around that. I don't care either way. When I learned it, it was a parenthesis. Now they're saying it's a bracket. Either way, whatever. I'm not particular on that. All right, it's also increasing from 2 to infinity because that's where the derivative is positive. This graph is decreasing from negative 2 to 2. Now, I'm not going to let you have your calculator for this. So So you have to decide if negative 2 is a max or min and if positive 2 is a max or min. And so, but if you look at this and you see on the left side of negative 2, our graph is increasing up to negative 2. And then on the right side of negative 2, our graph is decreasing. What kind of a point increases on the left and decreases on the right? A maximum. You mean, All right, so at x equals negative 2, that would be a maximum. And if you look at this one, you are decreasing to 2, to x is 2, and you are increasing on the other side of it. And something that decreases on the left and increases on the right is a minimum. Okay? Now, if I ask you for the point, you would have to then plug it back into the original function and give me the points. Now, if you didn't have your calculator, I probably wouldn't ask for that.
Are we going to have like 3 problems on this quiz?
I don't know how many problems are on there.
Because this is kind of a lengthy problem.
Is it? If you plug it in, you get negative 16, and then at negative 2, you get positive 16. So one's the max and one's the min.
Oh.
Yeah.
If it's a single point, are we allowed to use second derivative test or something?
Sure, go ahead. We don't know that yet. Don't listen to him. All right. Yes, 1 point is easy.
Oh, now you want me? Now you want my help?
I don't want you to teach that stuff I know.
No, I still think there is.
Do another one. All right, so polynomials, pretty easy, pretty good. Here we go. Number 2. And then we don't have polynomials, and they get a little tougher. And so let's do something like, oh, I don't know. Let's do f of x equals 1 over x squared. Okay, 1 over x squared. So we're not going to graph this on our calculator, but we are going to use analytical methods to find the local extrema and the intervals on which it's increasing and the intervals on which it's decreasing. So here we go. First step, take the derivative. Okay, you may want to rewrite this as x to the negative 2 so that you can take the derivative without doing quotient rule. Bring the negative 2 to the front and then subtract 1 off. And so you get negative 2 over x cubed. Now, does this ever equal 0? No, it doesn't. Set it equal to 0 and you try and solve, and there is no value that's going to give you 0. But it is undefined. It's undefined at what? 0. Okay, so that's an important point. All right?
How do you know that? What?
Because can you plug 0 in to that?
Oh, sorry.
It's undefined at 0. Okay? Yeah. And so what you're going to do is you're going to take your little number line here, and it only gets split up into 2 parts now because there's only one, point of critical point is what we call it. And so what you're going to do is you're going to test both sides. Okay? You're going to pick a number over on this side. Over here. What would you like to choose? -1. Me too. I'd pick -1 over here. And then you're going to plug -1 in. So you get into the derivative. Okay? You're doing f prime of -1. And when you do that, you get -2 over -1 cubed, which is still -1. So you get a negative over a negative, which is a positive. All right? Now you're going to test the derivative on this side.
1.
Yes, I would choose 1 also. And so f prime of 1 is going to be -2 over 1 cubed, and we get a negative.
Isn't it always, unless it's a line, isn't it always just going to be the opposite? They only have 2 sides.
A line?
Like, no, isn't it always going to be like one's positive, one's negative?
No, not necessarily. Like, if you tried to do y equals x cubed, that's constantly increasing. You would test both sides, they'd both be positive. We could do that one in a minute. I'll show you.
Oh, never mind.
All right, so then this graph is increasing from -infinity to 0. And then this graph is decreasing from 0 to infinity. Do you know what this graph looks like? The original function looks like? Looks like kind of like the Atari symbol, Looks like too old for you guys? Okay. No? There you go. See this graph right here? This is the graph of y equals f of x. All right? This is not the derivative. This is the graph of y equals f of x. On this interval from -infinity till I get to 0, do you see how the graph is constantly increasing? Over on this side, I'm up here and my y's are getting lower and lower. It's constantly decreasing. And that's what we did without graphing it, without looking at it. We just did it using derivatives. Okay? That's what calculus is all about. Calculus made life, before graphing calculators, it made Newton's life so much easier. It was beautiful. We'll watch a video. Oh, yeah, he's long dead. Okay, we'll watch a video on that sometime. So let's talk about that one, though. Let's talk about f of x equals x cubed. Okay? Yeah?
So there's, for the local extrema that we have to find for number 2, there's none.
There's none. Yep, exactly. There would be none there, which is kind of tough to decide, but if you did think, okay, what about 0? Maybe that's a max or min. When you plug it back into your original function, it's undefined. So it's not a point at all. It's undefined. All right, so here we go. Let's take the derivative. When you take the derivative, you get 3x squared. Set this equal to 0 and solve, and you get x equals 0. Okay? X equals 0 is where the derivative equals 0. Oops, don't draw that. Just draw a number line. And it breaks this up into 2 parts. And so if we test the derivative on this side by plugging in f prime of -1, it's positive. if we test the derivative on this side, f prime of 1, it's also positive. Right? So where is this graph increasing? It's increasing all the time. And people say, oh, but you're going to do negative infinity to 0, 0 to infinity, but it's all together. It's increasing the entire time on this graph. We know that because we know the cubic function. At 0, it flattens out so much that you get a derivative of 0 there, but it's not a great point. Remember, this was our bonus question. So there you go. All right, do you feel like you're doing pretty good? Do you need any more? You just need to remember to take the derivative, set it equal to 0, and then test your sides. If it does have like 27, actually, I think 23, 25, and 27, you can do those graphically. Because it doesn't say to do those analytically, you can graph them and look to see where they're increasing, decreasing, max, mins, okay? So graph those, but the rest of them, 15, 17, 19, 21, you need to take the derivative, set equal to 0, and find those numbers, okay?